So welcome back. This is part 2 of the amplifier build of my latest project, and I've come down to, as previously mentioned, I've got this transformer. I'm using the SE200 power amplifier modules along with some cat6 modules. These are available or as a module. I don't think Avondale will supply you just with a PCB anymore. He may, I don't know, but I think he just supplies you with a module. In actual fact, it might be a cat6 type module. In actual fact, I think they're on his website actually. By the by, the reason why I'm doing it this way, you can buy this case, you can buy these modules pre-built by Avondale, ready to go. They're tested. You don't have to messing about trying to source components and messing about like that. That's available as a module. This is available, the power supply. So it's just a matter of, in effect, it's a little kit that you put together yourself. And you'll end up with a stonking, a superb product that anybody would be proud to own. And the fact that you've done it yourself, there are some provisos. Electricity can kill you, 240 volts AC can kill you, so you must take precautions. You must be very, very careful with what you're doing, step by step by step. This metalwork has to be earthed to the mains earth, and then it's strapped down. It's called strap this down to the earth. That's the first thing I do when I put the AEC socket in here. My first job is to wire in the earth to the chassis. So that no harm can come at a later date. So I'm going to proceed. I've got to drill some holes, obviously, to mount these at a given space. So I'm going to mark these out and just drill some holes and fix these in place along with the transformer. Thus, I do have, actually, I don't think it's needed in this case, but I do have, this is something else, a bit of an Avondale promotional video this, isn't it really? This is an Avondale SSM2 soft start module. So this goes between the IEC socket and your transformer, your mains in. And this drops the voltage to about 180 volts for a little while, so that this transformer is sort of soft started, so there's not a huge inrush of current. I had a problem here where my breaker in my box, I couldn't even start a 350, couldn't switch on a 350 VA transformer. It would trip the RCD device in my consumer unit, and I've had to go to a what they class as a C type, which is an uprated soft starting milliamp current. But if you do have trouble, you can utilise these. I don't think I need it on this, but just as a proviso. So moving on, these existing holes that were here on this heatsink, I've utilised those, and I've drilled and tapped some M4 holes here, so that I can just screw that through there onto this heatsink. But before I do that, in plain sight, I'm just going to give it a little squirt of heat paste, not too much, doesn't need a lot. More than enough, that is. Spread it about, that's too much actually. Far too much. Oh, a chunk of that will be going on the other one. You only need a tiny little amount, and that's too much. But anyway, some of these can end up with a nice splodge. So some M4 cap heads goes through these fins, and we just align these with the holes I've drilled and tapped in the amplifier module. Don't do them up straight away. If I'm following the hole, that's it. So you just wind him up gently, gently, gently. Of course, do the other one. You can do it the other way around if you wished. You could drill and tap the heatsink and put a screw through underneath the amplifier module. The problem with that is if you need to remove the module at any point, it's a right swine to be able to gain access. Sorry. So there's the module. Just line it up a bit. That's it. Well, here's a delivery of some parts. I'll be back shortly. So this is nicely nipped up. Don't have to strip the threads, but it's nicely on the heatsink now. And see what I'm saying about if you could drill and tap the heatsink and put the bolts through this way, but you'd have to have a very long reach Allen bolt, and if it's in the amplifier, it's a right pain to try and access it if you needed to. So that's that one. I've got to go and do the same to this side. I've already just drilled the hole through the chassis base plate, if you like. I've also drilled some holes for these little mini cap 6s. I've got to put some capacitors in here, do that, IEC socket, and then we're ready for some wiring. I'm going to go and give this a bit of a clean. But let me just get on and do this one and I'll be back. So here's the second module. This time far less paste. That's all you need, and I'm going to spread that about with my finger. You could use a brush, but I use my finger, just like that. That's all you need, is a smear. That's it. And it's back to putting this on the heatsink. Bear with me whilst I line it up. I can't do this on camera. I'm flying blind behind the camera. So there's a second one on that heatsink. Just drop this side down a bit to line it up. Not that anybody's going to see it. Nobody's going to know, as they say. But it's lined up with the chassis rail. So we end up with something like that. That go on the back. Put the heat paste away. Don't need that. Try again, shall we? That's it. I'm just going to open a box. Take the money or open a box. Only people of a certain age will understand that. Yeah, make a boot to go over that. I've got some nice heavy duty female receptacles to replenish some stocks. I'm nearly out of these. These seem fairly substantial, these, a bit like the RS ones, but these are like half the price. 16 to 14 gauge, 6.3. There's 100 in there. And if you're in the DIY, you eat these for breakfast. You use loads of them, loads and loads of them, as you'll see as I start to wire this up. So my next port of call, just checking the battery, now we're okay. We're okay, is put these bits away. I've got another box. I've got another delivery here. Again from Rapid. I have no preference for any supplier, as long as it's a bona fide supplier, I mean, for kit. Some of these components, dare I say it, are iffy. Even from bona fide suppliers can be a bit iffy. But anyway, huge box for these, for capacitors. And that's the fact these might not be the ones I need. Let me see. These might be, oh, sorry. Oh no, they're the wrong ones. They are the wrong ones for this application. They're 32mm in diameter, so you can't get two side by side in a Cat 6. Damn. So you have to be very careful. I'm not going to say this is wasted, but this is 68 quid's worth. 68 quid, which at the moment I can't use, but I am going to use it. I am going to use them. I'm going to use them in these, the Cat 6. The reason I didn't use these initially, or didn't think, was because the capacitors are only 85C, and these date back to 2012, so they're quite old. So what I'm going to do is take these out. These are 5.6s, 5600s at 100 volts, and replace them because they're old. There's nothing wrong with them, but I'm going to sell this. This amplifier is going to be sold, so I'm going to replace them with the modern 6800 63 volts, and they will go on there. So I haven't really wasted these. It's just a nuisance. It's a nuisance. That's my fault for not paying attention when ordering kit, and no doubt everybody's done it. get all excited. The box turns up, open the box. Oh no! Open the box, take the money. They've taken your money and you've got the wrong bit of kit. So I'm going to clear the decks now, and I'm going to whip these out, take these capacitors out and replace them with these new ones. These are new within, well, less than 6 months. This is new. We're going to forget that, obviously. Can't use that. And I will replace these. So I'll be back soon. So, desoldering. I'm going to do it the old-fashioned way. Get some nice heat on there. This is an old sucker where you just suck that off. If you're not having, this is quite deep, so if you're not having much luck, a swift tap like that. Then I'll get plenty of room out. So you don't want to do it like that. So you have to tease and you make it yield, is a modern terminology. There we go. So that's one way of doing it. Let me go and get another piece of kit and I'll show you another way of doing it. See that? So I've got one of these desoldering, cheapo, cheerful desoldering station, and you just plug it in. He says. So I have to wait for this machine to come up to temperature. I'll be back. So we're up to 480 degrees. Soldering iron and a vacuum pump. We'll see how we go, shall we? So apply the heat. It just sucks it straight out. And what I have found on this bigger, especially on these bigger things, larger amounts of solder, if you preheat and then go on after, it's much nicer at removing the solder. So you're giving it a helping hand, obviously, because the tip, that's the biggest tip, and not quite man enough really, but you can see it quickly disposes of all that solder. My only gripe is sometimes it gets bunged up very quickly. Well, it's not my gripe, it's everybody's gripe with these. Even the good ones do the same thing. They get clogged up with solder. And the other thing I've noticed, if you let gravity help you by turning the work upside down, it seems to help. Now that, as you can see, has got rid of 99% of the solder, and on this big stuff you would more than likely have to go along and just tease these legs out with a bit of heat because they're snap fit anyway. So gives a bit of a squirt. I've just gone and cleaned up these pads that I've just desoldered. So now we get our new, there's the old, out with the old, in with the new. So negative to the centre, positive to the centre, not very snappy, are they, as they say. So positive down this side, negative down this side. Now I've got to turn the whole thing over if I can, without losing any. So what you have to do is just bend the pins just a little bit, just a tad, just so they snap in. That's better. So that one I'm just going to go like that. It's just a fraction, it's just a fraction, and it just, you can hear it snap. Like that. So I'm just bending these pins just a fraction, just to make sure. The other way is to glue them in, but yet again, if you do that, they're swine to get out afterwards. So there we go. And the last one. So now you can turn them over. There you go. So I'll just give this a quick wipe down with the old isopropyl alcohol. Let me brush. Damn good cleaning. There we go. Now these have no chokes, there's a dead short across the. So here's the test. I'm going to wind some AC volts on here, and we'll see some DC volts turning up here. There we go. So we'll take that up to 240, 200, 220, 230, 240, and we got 52 volts on the negative rail. See the negative? We'll swap that over to that side. And we've got 52.5 there, so that one's all good and tested. So I'm just going to sting this. I've got my little stinger, so I've turn the power off, but there's still 52 volts and quite a bit of energy. So a little stinger. It is a so just a 4 ohm 10 watt metal case resistor. We go to the ground and to positive terminal. All the energy is gone. Do the negative terminal. You can see it returning. They sort of self-generate. There you go. So all the energy is gone now in this particular unit, so module. So that's that one. I'll carry on and do this one, and I'll be back later. Alright, see you soon, bye. I've mounted the transformer on this bottom chassis. Just some M3s, brass M3s I've used. We're not holding up the fourth bridge, and it's a bit of a, as I said right at the beginning, this is just using up what's on the shelf really. So we're getting somewhere near it now. There's the two modules mounted on the heatsink. Thus, true Captain Mannering style. Like that. If it'll go on, if it'll stay on. Something like that. There's a butterfly. So, I'm going to start screwing this together. It's just a simple matter of screwing it all together. And then I'll start wiring. We do some wiring. So I'll be back soon. Oh, here we go. So I'm putting in some serious self tappers. Let's line this up. Screw the back of my head. So to be able to use these, you have to knock out the nut. It's called a nutsert, I think. The nutsert that's in an existing hole. In here there's a nutsert. Well, we're just about to knock it out, I think, with one of these. No, not quite. I'll get something more substantial. Like a drill. Everything you're not supposed to do. Like that. He comes straight out like that with a nice big fat PK. There it is, nice one. That looks like a good one, and we're gonna wind that in. Sorry. So there you go. So now we're going to flip him over. Now we're getting somewhere near it, aren't we? One, two, three, four of those. There should be 4 nuts in there, and 4. This Those on there. Boring, boring, boring. Or it may not be for some. You got to do a bit of twisting and jiggering and poking to get these cases, chassis, whatever you like to call them, to line up correctly. They're not the easiest thing in the world to get to line up. So what I do, I put it together loosely so that there's some movement. I know I've bolted the bottom down, but this back panel is just loosely put in place, because when we put the front one in, the front aluminium fascia, you need a bit of wiggle room to be able to get it to fit in. Anyway, one more. Like that. Now we're making progress. So as previously mentioned, they've got two secondaries, 35 0 35. We're going to come off here, drop onto the AC in end of these Cat 6 modules, and then we're going to wire up to here and then to the outputs. The AC mains is pretty straightforward really. There's just two. I've got a boot that goes over this, which will protect that, and of course we'll strap all this down, and we'll strap the earth as well. That'll be soldered on. So I will carry on doing that. I'll tidy this up. Yeah, we'll make a lovely job of that. Everything's out of the way. So there's going to be a lovely little amplifier for somebody somewhere in the world. See you soon. So I've wired up this AC this side, as you can see, nice and neat, and the easiest way to lace this up nice and neat is to warm these up with your heat gun. With a little pull, gently tease them out. Just like that. And we start zipping up in an orderly fashion. Try not to cross them. There's all sorts of theories as to what should and shouldn't be twisted together. So now, because it's so pliable, I can actually route this wherever I like. We're just going to come down there and come across the front like that. So away you go, just lace it up nice and tight, nice and tidy. that. You need to tie on the bend where you're going to go, and that will hold that bend when you twist it round. I'm hoping you can see this. Let me have a look. Yeah. So we want a bend there, so you give it a good force it round. We got a kink dog leg in it there. We're going to come along here. There's another cable tie the other side of this bend. I'll hold it there. It's all a bit fiddly, but it's very satisfying in the end if you can master this. Get it all nice and tidy and neat, looking good, professional. So many manufacturers of this modern kit, they use ribbon cables because it's in effect it's plug and play. There's nothing wrong in that. This is just an old-fashioned way of doing it, really. I mean, I've built amps that don't use. That's lovely. Smash in, get some more zip ties. Put one in here. Hold it in place. Lovely, and then we can go and tidy this lot up, take all this off, all the ends. It's amazing waste when you consider you're only using 10% of the plastic. Throw that lot away. I don't know if it is any good for anything else. Now I've already got terminals on here, but they're too long. They're just tad too long to make it nice. So I'm just going to snip these off. Yeah. If I make them the same length, they'll turn the same. So I'm going to take that off there, about there. A little bit shorter. Probably I'm making it look too easy, but I've done so many of these. Get yourself a nice pair of strippers. Set them up correctly so that they do not take any conductors out. They only take the sleeving off. I'm doing this very cool. I'm just checking my battery. We're okay for a second. So want 3 sleeves. Couple of more of these. So you put your sleeves on, there's your 0. Turn them over and crimp, turn them over and crimp, and then we just go and knit that tight like that. Next one. I'm rushing a bit really because of the battery on the camera. I don't know, it seems to just die, so I'm brushing this a bit. I'm waiting for it. It doesn't go beep. It used to go beep beep, and I've yet to find out how to reset that beep when the battery's getting low, and it would give you like 5 minutes warning. But okay, and then what we're going to do is do a bit of soldering. We're going to, so we've mechanically strapped the cables, the conductors to the terminal, and we're now going to solder the little blighters in place. So there's actually a gas tight seal, and that's not the way to do it. Oh. I shouldn't have put this one on, should I? It's, there we go, watch. I don't know if my head's in the way, apologise if it is, but there we go. Let it flood, one more, this one here. Let gravity help you if you can, let it flood downwards. There you go, so you see it flood away. Let it cool off for a second. So there's your centre. AC that side, AC that side. Just a little bit of a turn on the cable, so it's not stressed. There's no stress on the cable. So that's the AC element. You'll notice that on this side, on this Cat 6, I've got screws and caps and nuts and the rest of it. On this side, I just used some super glue, thermal super glue, as an experiment, as opposed to nuts and bolts, and it's absolutely solid. It's well good, works perfectly. So that's that side. I need to talk now slightly about the DC side. I'm going to change my normal modus operandi, and I would normally carry on wiring up in 20.6 wire. As if you've watched my previous videos, go back, and it's just machine wire, 20 strands, copper. Oh, that's signal wire, sorry. Here's some. It's 20 strands, 0.2. It's a bit better than what mainstream manufacturers use, but on this occasion, these are audiophile boards, sort of. So we're going to use audiophile cable, which is aviation spec, silver plated, pure copper, PTFE, nylon if you like. It is like welding wire. This is 19 strands of 0.35, I think it is. You can go and look it up on the internet. It is. Let's see if it's find a number on here. Here it is. I don't know if you can see that. It is M military 22759 57104. So I'm going to wire all the positive in orange, all the negative in blue. That's what it looks like. I don't know if it'll focus. Oh, yes, fine. Yeah, there you go. And all the earths, of course, are going to be green. So it is hard work because there are there's three 0 volts on each board, plus a 0 that goes back to the speaker terminal. So there's quite a bit. I mean, this stuff isn't cheap, it's quite expensive. But I'll start off. We'll start off with, I'll just roughly gauge how much we need, because we're going to go from the 0 volts, which is the red on the Cat 6, and we're just going to come down here. We might offset it slightly. Come down here, and we need to get to the 0 up here. So with a few bends, I'm going to just about there. something like that. Oh, blimey. Now, I don't know if you're going to... Sorry, I'm knocking you about here. I don't know if you're going to have to be able to see this. Come on. It doesn't. This doesn't rip that off. This PTFE is so slippery, so stiff, so strong, if you like. You've got to do a funny little thing with it. But anyway, put your sleeve on. Same as before. You can see the size of this conductor. These conductors. They only just fit in here. It's 2.5 mil. So auto focus, it says. There you go. Not quite right, but I have got a pucker crimping tool, which I don't get on with, but I like this one. It's doing it. It's more a bit more feel for this. There we go, lovely. I apologise if this is slightly out of focus. Like that. Same again. Same modus operandi. We use a bit of paper. This takes a fair bit more heat. Is this silver solder? No, it's not. This is good old tin lead. And you can see that flooding. I'm hoping you can see that flooding down. I'll put a bit more on there. Lovely. So hopefully you can see you end up with a nice finished job. Put your sleeve on. Oh, going from the. Sorry, you're not going to see this bit. You're only going to see me back, but all I'm doing is connecting this to the zero. To the zero. We're going to come up a bit. And come across here. So we're going to have the zero that comes off of this zero here, off the centre tap of the transformer. It's going to come along here over this board and connect directly to the negative terminal of the speaker binding post, which you can't see here. We're going to come all the way down there and connect into this binding post on the back panel. So that's the first one in. I'm going to go away and come back after I've done one side and you can see how we're doing. See you soon. So after a little while, some time actually, this side is now complete. So we have a positive off of the power supply, goes to the positive on the power amp board. The negative of this power supply goes to the negative V minus on the power module, We got 1, 2, 3 earths all go back here to the centre of the power supply unit, or CAP6 module. The earth to the speaker terminal, 0, goes all the way back and is connected at the head end of the PSU. Speaker output is the orange, goes here, and we've got signal connected ground via this phono. So that side is now complete. That's the conclusion of part 2. Thank you very much for watching. I hope you enjoyed it a bit. It's a bit of fun. Hopefully entertaining, if nothing else. And in part 3 I'll be finishing off this side and then set up and test on the bench. So that'll be the bias and offset setup. So thanks for watching. Thanks for all your kind comments. Hope you enjoyed it.